Welcome to this channel. Myself Akshat Jain, and today we'll be talking about NumPy. So far we have practiced in Python about arrays and lists, and we have found one thing, that when you try to go with big data, Python usually starts to process things slowly. So in order to deal with such kind of problems, people came up with a NumPy. So in this session, we will be talking about NumPy, what is NumPy, why NumPy is used. So this playlist is divided into 10 sets of chapter, and today we'll be talking about chapter 1, which is moving beyond the limits of standard Python. So here we'll be considering two characters. One of the name is Leo, a person who want to learn about NumPy, who has gist in learning NumPy, and the one person who is Noah, who is a guide to Leo. Well, without wasting any time, let's begin our session. So basically, um, Leo is a person who is a relatable developer who is hitting a wall with a slow code, and Nova is a visionary architect who provides the grid of this solution. Okay, so now what happens is that, so now suppose consider a scenario where Leo is processing suppose 10 lakh or 1 crores of data set, where the data points are the progress bar is still stuck at 15%. So now here, well, the Leo gets frustrated, like my code is crawling, why is Python acting like it's climbing a mountain? So well, I'll give you the explanation for this. Explain the standard Python lists are versatile, but struggle under the weights of massive data set. Now what happens is that a list, it has to be ready to hold strings, integer and object all at once, because it is a messy drawer where Python must open every box and read labels. It is slowly at everything. When it comes to NumPy, it is an engine under the hood of AI. It doesn't do everything, it only does numbers at a lightning speed. So basically NumPy is only used for numbers. Okay, so now when we talk about a list can have a number, a string, a bool, or anything. But when it comes to NumPy is a jet engine for numbers. It doesn't do everything, it does numbers at lightning speed. Okay, so now let's talk about some architecture of a Python list. So basically, when I ask you, like, describe the NumPy array as a steel grid. So since data is uniform and packed tight in a contiguous memory block, the CPU can process a whole row at once. And vectorization, so iterative loop, adding 1 plus 1, then 2 plus 2, 1 by 1, with a single heartbeat operation. So tell the student, you don't tell the CPU to add one by one, you tell it add these two grids. Okay, so basically when we think that how we are talking to computer, it's like add 1 plus 1, but no, it doesn't happen in that way. It tells add these particular grids. Okay, so now the architecture of NumPy array, something looks like this: a contiguous memory block, and no boxes, no labels. The CPU processes the whole row at once because the data is uniform and packed tight. I want you to note this point, that there are no boxes, no labels. The CPU processes the whole row at once because the data is uniform and packed at a tight speed. And now when we talk about power of vectorization, which I just spoke before, is that now suppose consider vector array A, which is 1 2 3 4 5, and another array which is 1 2 3 4 5. Now what happens is that basically, uh, in iterative loops, it goes step by step, like 1 plus 1 equals to 2, then 2 plus 2 equals to 4. But in vectorization things happens at a unique speed. So basically when you try to add two vectors, those numbers aren't get added, grids the numbers in those grids gets added. So basically you're adding a grid, not a number in this. Remember what I'm trying to tell you. Okay, so next comes meet the nd array and dimensional array. So there are one dimension array, two dimension array, and three dimension array. So what is an nd array? So whenever you try to write something or create an array in NumPy, and then you try to print the type of that array, Python will show you it, I'm sorry, it's the compiler which will show you as an ND array object, which allows data to move as a single unit regardless of its shape. So now here comes of okay, we have talked this much about Python. Contiguous memories, grids are added, does lightning speed, handles crores of data in seconds. Okay, but come on, let's begin. Stop talking something and tell us how can we start this. So well, here we are going to type pip install numpy, which fetches the numpy, and then once your numpy is downloaded, we will import numpy into our notebook. So basically I prefer using all the data related work in the notebook itself. So NP is a universal standard alias used by the entire data science community. You can use import numpy as abcd, but which is not much more preferable. I would recommend you to use NP. So NP is an universal standard alias used by the entire data science community. So now let's create an NumPy array. So basically, when you try to create a Python in Python list in a Python, you usually use mylist and then 10, 20, and 30. But when you create a list in using NumPy, you have to always mention np.array. So when you use np.array, the given list is converted into an NumPy. So what Nova is trying to tell is that it takes your old list, which is a slow, and then accent it into a NumPy array. Okay, so basically we are talking about here, and now when we are trying to talk is that preparing the battlefield. Okay, so now suppose we have grid equal to np03 comma 3. So what does this command mean? So np.zeros, so np.zeros is something which tells that I have a grid of 3 cross 3, which is 3 rows and 3 column, and each of those rows I need those numbers to be 0. So basically when you write this command and when you run this, you'll find that a, a, a grid of 3 cross 3 is created, and when you try to check the type of those grids, say suppose if I'm checking type of np dot zeros 0 bracket 0 square bracket 0 square bracket 0, so you will get output as an float. Okay, so something when you see in this format, it's kind of, you understand, right? How things are going and what's the logic. So now specialization, numbers over general purpose. So what are the specialization of NumPy? So numbers over general purpose, contiguous memory, the steel grid over a messy drawer, and vectorization, a single heartbeat operation. And with this, welcome to the learning of NumPy. I hope you enjoyed this. In the next session, we will be working on live code session of how can you install NumPy, and we will discuss all these topics again in live code session.